Hey guys, here's the review video on graphing equations and systems of equations. All right, question one. Determine which of the following points is a solution to the equation y equals negative x plus 6. So we have an equation here, and we're asked to determine which of these points is a solution to the equation, right? Essentially, which of these points would make the equation true? There are two ways to do this. We can do it algebraically or we can use the calculator. So I'm going to show you first how to use the calculator. So you want to go to Menu, Table, hit Enter, and then let's enter in the equation negative x plus 6. Hit Enter again, and then here we have our table of points. So any point in this table is going to be a solution to that equation. So we want to check to see which of the points that we're given in the answer choice is on our table. In choice A, we have -2, -1. So on my calculator screen, I'm not seeing any of the negative values. So to see the negative values, I can just type in -2 and hit enter. So -2, hit enter, and we see that when x is -2, y is actually 8. But in our answer choice, we have -2, -1. So obviously we can eliminate A. It's definitely not going to be A because A, the point in choice A is not on our table in the calculator. Choice C, we have 1, 6. So on my calculator, if I hit 1 and then hit enter, I see that when x is 1, y is 5. So obviously I can eliminate C as well because 1, 6 is not on the calculator. On the calculator, when x is 1, y is 5. All right, choice B, we have -3, 9. So if I hit -3 on the calculator, hit enter, there we go. -3, 9 is on the table. Therefore, -3, 9 is a solution to this equation. So our answer here is going to be choice B, -3, 9. And then in the calculator, if you look, uh, when x is -3, y is actually 3. So we could have eliminated choice D as well. All right, cool. The other way, if we were to do this like by hand, algebraically, we can substitute the points, the x and y values into the equation and check to see if it would make the equation true or if the left side will equal to the right side. So let's check. Let's do that using the point -3, 9. Okay, so we know that the first value is always going to be our x and the second value is always our y. So in my equation, I'm going to substitute 9 for y. So 9 is equal to negative -3 plus 6. I want you to notice here in the equation, we have a negative x, and in our solution, we have a -3. So since this x is negative in the equation and our value for x is also negative, I need to have a double negative when I'm substituting. That is where I'm getting this negative negative from, right here, because there's a negative in the equation and the value that I'm substituting is also negative. Let's simplify that. This entire part right here that I just highlighted, you can put that entire part in the calculator, that entire expression in the calculator, and simplify it if you're not sure about the double negative signs. But we know that a negative times a negative or a double negative will become a positive. They cancel out. So 9 is actually equal to +3 plus 6. Simplify that. 9 is equal to 9. That's true. So the left side is equal to the right side. The point -3, 9 does make this equation through. Therefore, it's a solution. All right. think I think I over-explained that, but okay. Question 2. What is the y-intercept of the graph of the line whose equation is y equals negative 3x plus 12. So when we have an equation that is in slope-intercept form, y equals mx plus b, we know that our y-intercept is always going to be that b value, right? The value, the constant in the equation, right? The value without the x, without the variable. So in the equation y equals negative 3x plus 12, our y-intercept is going to be 12, right? That's our b value. That's the value without the variable x. So our answer here is 12. This y-intercept is also the point where the line crosses the y-axis, if we were to graph it. Okay. Um, question 3, sorry. One possible solution to the equation graphed above is. So we're asked to determine which of these points is a solution to the equation that's graphed. When we're looking at a line that is graphed, and we're looking for a solution, we're looking for points that are on the line. So any point that I pick on this line would be a solution to the equation that's graphed. So let's check to see which one of these points is on the line. If I plot the first one, A, to 100, we know that it's always x comma y. So if I go to 2 on the x-axis, and then I go up to 100, that's going to be this point right here. Obviously, that's not on the line, so A is not the answer. B, 10, 10, 25. If I went to 10 on the x-axis and I went up to 25, maybe somewhere around here, we see that that point is also not on the line, so B is not the answer. C, we have 0, 450. So if I go to 0 and then I go up to 450, that's this point right there. And then that point is actually on the line, right? Also, this point is our starting value, which means that it's also our y-intercept, right? This is the point where the line is crossing or touching the y-axis. So our answer here is 0, 450. And then if we just checked, just for checking's sake, the point 24 comma 0 would be over here. And obviously that's not on the line as well. All right, cool. Question 4. What is the solution to the system of equations below? So we have a system of equations that's graphed and we're asked to determine what is the solution. When we have a system of equations and we're trying to find the solution to a system of equations, all we're looking for is the intersection point, right? The point where the two lines cross each other. Obviously, that is right here, right? These 2 points are intersecting, crossing, touching right here at this point. So what is this point? Let's find the x value first. If I'm starting at the origin, right, and we're always starting at the origin, to get to this point, I need to go over 1, 2. 2 units. So 2 is my x. And then once I'm at 2, I have to go up 2. 1, 2. So my y is also 2. Right? That's how you read the coordinate points. Always start with the x. X is going left or right. And then the y, which is up and down. If you're going to the right, it's positive. If you're going to the left, it's negative. If you're going up, it's positive. If you're going down, it's negative. So this point 2 comma 2, that's the intersection point. That is the solution to this system, which is choice C. All right, cool. Question 5. Which of the following is the equation for the line graphed above? So we are given a line that is graphed and we're asked to determine what is the solution. So we're sort of working a little bit backwards here. Um, so when we're trying to determine the equation of a line, we can use the slope-intercept form, which is y equals mx plus b. So we know that we're going to need to find out what is our y-intercept and what is our slope. B is our y-intercept, M is our slope. Let's start by finding the y-intercept because that's the easiest to find. So our y-intercept is the point where the line crosses the y-axis, right? We can see that that is going to be right here, right? This line is crossing the y-axis or touching it right here at this point. So that's my y-intercept. What is this point? Well, it's 0, 2, right? So my y-intercept here is just 2. So I can substitute that, now that I know that it's 2, I can substitute that into the slope-intercept form equation. So I'm going to have y equals some slope x plus 2. Notice that my y-intercept here is on positive 2. That's why I have a addition sign in my equation. Now I need to find out what the m is, right? What's my slope here? So if I'm at the point 2, that's my y-intercept, and I'm trying to get to the next point that is perfectly on this grid. So right here, if I'm starting at my y-intercept, I'm trying to get over here. How much do I have to go up and to the right to get there? Well, I'm going up 1, and then I'm going to the right 1, 2, 3, 4. So I'm going up 1 and then to the right 4. So we know that when we have um, a number going up, that would be the numerator or the top number in the fraction. And then when we go to the right, that would be the denominator or the bottom number of our fraction. So since we're going up 1, that's going to be the numerator. And then we're going to the right 4, so that becomes our denominator, right? Up 1, right 4. So this is our slope right here. So let's plug this into equation. So y is equal to 1/4 x plus 2, right? So we're starting at 2, we're going up 1, and then right 4. All right, and that's it. That's our equation, which is going to be answer choice. There was a typo here. It was this answer choice was not in here, so I'll just write it in at the side. All right, let's make up answer choice E. Y equals 1/4 x plus 2. All right, cool. Okay, question 6. A cell phone company charges $80 a month for up to 1 gigabyte of data. The cost of additional data is 10 cents per megabyte. If M represents the number of additional megabytes used and T represents the total charges at the end of the month, which linear equation can be used to determine a user's monthly bill? All right, so this cell phone company is charging $80 a month, and then it's charging 10 cents per megabyte. And then M is representing the number of additional megabytes, and T represents the total charges. So if I'm writing an equation to represent this, I'm going to start off with T because T is my total. And then it's telling me that it's $80 a month for 1 gigabyte of data, right? So I'm starting off here with I'm starting off by paying $80 upfront, right? You can think of that as like the one-time fee. So I'm starting with $80 for just 1 gigabyte of data. That's standard. And then if I go over that, right, the cost of my additional data is 10 cents per megabyte. When we have the word like per or each, we know that that's usually the value that's going to carry the variable, right? That's the value that's increasing. Every month I'm paying 10 cents per megabyte that I use, right? So that's going to be plus because it's an additional charge, and then 10 cents to 0.10, and M for additional megabytes. So my equation here is 80 plus 0.10 M, which is choice D. Okay, that's that. Question 7. On the set of axes below, draw the graph of the equation y equals a half x minus 2. And then we're asked to determine if the point 32 is a solution to the equation. Okay, cool. So if we're graphing this equation, y equals half x plus 2, we know that we're always going to start with the y-intercept, right? Our y-intercept here is -2 because it is the b value, it is the value without the x, it's the y-intercept. So I'm going to go to -2 on the y-axis, which is going to be right here, -2. And then my slope is a half, right? We know that the top number or the numerator is telling us how much we go up or down, and the bottom number, the denominator, is telling us how much we go to the right. So here I'm going up 1 and right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Okay, once I have a few points, I connect those with a line. And since this equation has infinite solutions, right, this line can go on forever, we're going to add arrows at the end of this line, right? That indicates that there's an infinite number of solutions here for this equation. Um, cool. And then we're asked, is the point 3, 2 a solution to the equation? Okay, where is the point 3, 2? Well, if we go to 3 on the x-axis, we know that this is xy, right? So go to 3 on the x-axis, 1, 2, 3, and then we're going up 2, 1, 2. Here's the point 3, 2. Is it a solution? No, it's not, right? And we're asked to explain our answer. So we would say, no, 3, 2 is not a solution because the point is not on the line. For a point to be a solution to an equation that is graphed, it has to be on the line. Um, so I'm just going to write that here. No, because it is not on the line that is graphed. Okay, cool. And that's it for that question. Question 8. On the set of axes below, draw the graph of the equation, write the slope-intercept form, slope and y-intercept of the equation. So we have the equation 2y minus 10x equals 18. So we're asked to put this equation in slope-intercept form. So to do that, we need to solve for y. We need to put it in y equals, right? We know that the slope-intercept form is y equals mx plus b. So we need to take our equation here from standard form to slope-intercept form. All we're doing is solving for y. We're trying to get y by itself. That's it. So I need to get this 2y by itself. I need to move the negative 10x over to the other side. How do I do that? I just use inverse operations, right? I do the opposite. So here we have a negative 10x. What's the opposite of negative? Positive, right? So here, if I want to get rid of the negative 10x, I'm going to add 10x. Okay, that's not how I write the x, and it's bothering me. All right, so I'm going to add 10x to both sides. This is going to cancel. Negative 10x plus 10x is just going to cancel out. And then I'm left with 2y is equal to 18 plus 10x. We can't combine these because they're not like terms, so I just rewrite them individually below. Now I have 2y. I need to get the y by itself. To do that, I'm going to divide both sides of the equation by 2. We know that this is 2 times y, and the opposite of multiplication is division. So I'm dividing both sides by 2. The 2's will cancel out, and we are left with y is equal to 9 plus 5x. I am trying to decide where I want to write this because I don't want it on the graph. All right, you know what? It's fine. I'll just leave it right there. All right, so yeah, so we're gonna have y is equal to 9 plus 5x, right? 18 divided by 2 is just 9. That's how I'm getting that 9. And then 10 divided by 2 is 5, and we keep the x. Okay, so where they asked us to write the slope-intercept form, this is the equation in slope-intercept form. So y equals 9 plus 5x. What's the slope? Our slope is always the number in front of x, the value in front of x, the m value. So our slope here is just 5. And don't write 5x. It's not the with the variable. It's just the value by itself, right? So it's just 5, not 5x. And the y-intercept is obviously the value by itself, the value without the x, which is just a 9. So my y-intercept here is 9. Okay, cool. Let's graph this. So we always start at the y-intercept. So I'm going to start at 9 on the y-axis. So let's go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my slope here is positive 5x. So I'm supposed to go up 5 and write 1. Since I don't have space on this graph to go up 5 and write 1, I do the opposite. Instead of going up and to the right, I would go down and to the left. So from the starting point of 9, I'm going to go down 5, 1, 2, 3, 4, 5, and left 1. Down 5 and left 1. Cool. Once I have the points, I connect those using a line, connect those with a line. This equation also has infinite solutions, so we're going to put arrows on the ends of this line. And that's it. Cool. Question 9. On the set of axes, graph the following system of equations and identify the solution. Okay, so we have 2 equations here. We're asked to graph them and identify the solution. Notice that none of these equations, neither of these are in slope-intercept form. So to be able to graph them, we first have to put them in slope-intercept form. So all we have to do here is solve for y, right? We need to put this in the form y equals. So in the first equation, um, I'm going to start by subtracting the 4x from both sides. Remember, I'm using inverse operations here. So since this was a positive 4x, I'm going to subtract the 4x from both sides. This cancels out. And I'm left with y. Oops. Y. Where's my pencil? Y. Okay. Y is equal to 2 minus 4x. Cool. And then in the second equation, I have x minus y is equal to 3. So I'm going to start by subtracting the x from both sides. That cancels out, and I have negative y is equal to 3 minus x. Notice that this says negative y, but I need positive y. So I have to get rid of this negative. How do we get rid of the negative from in front of the y? Well, we know that this is technically an invisible -1. So to get rid of that, I'm going to divide both sides, right? Divide by what's in front of y, so we're dividing both sides by -1. This will cancel out, the negatives will cancel out, and I'll just be left with y is equal to -3 plus x, right? 3 divided by -1 is -3, and negative x, or -1x, divided by -1 is just positive x. So now that I have both of the equations in slope-intercept form, I can graph it. We're going to graph the first equation by starting at 2. Our y-intercept is 2, so on the y-axis, I'm going to put my first point on 2. And then our slope is -4x, right? That means I'm going down 4, right 1. Down 4, right 1. Okay, if I were to do it opposite, in the opposite direction, I would go up 4, left 1. Connect the points. That's a horrible line. Arrows, because this line can go on forever. It has infinite solutions. And when we are graphing a system of equations, we need to label one of the lines. It's very important you label one of the lines, just so that we can know which one is which, right? So this was the equation 4x plus y equals -2. When we're labeling the lines, we want to label it with the original equation, not the equation that we put into y equals, right? So the original equations for this purple line was 4x plus y is equal to 2. So when I'm labeling this line, and I'm label it right at the bottom here, I'm going to label it with the original equation, 4x plus y is equal to 2. All right, let's graph the second equation, y equals -3 plus x. So I'm starting at -3, so I'm going to go down to -3, put my first point, that's the y-intercept, and I have plus x, plus 1x. That tells me that I'm going up 1 because it's positive, and right 1. So up 1, right 1. Up 1, right 1, and down 1, right 1 are the easiest and quickest points to graph. What a horrible line. We're going to do that again. I'm going to do that again. Okay, it will have to do. And then attach arrows on the end of the line. It has infinite solutions. And I think lastly, we are asked to determine, yes, we're asked to identify the solution. Um, since we labeled the purple line, we don't need to label the pink line because we know that if the purple is 4x plus y equals 2, obviously the other line would have been the x minus y equals 3. Um, and identifying the solution. Well, the solution is the point where the lines intersect, right? It's the intersection point, which is right here. What's the value of that point? Well, if I'm starting at the origin, I have to go 1 to the right, so 1 on the x, 1 for x, and then I'm going down 2, 1, 2, right? And since I'm going down, that's negative. So it's 1 comma -2. So in 1, -2 is my solution. Okay, cool. Question 10. Okay. Anna plans to spend $30 on balloons and party hats for her daughter's birthday party. Including tax, balloons cost $2 each and party hats cost $1.50 each. The number of party hats Anna needs is twice as many as the number of balloons. If X represents the number of balloons and Y represents the number of party hats, write a system of equations that can be used to represent this situation. Wow, what a word salad is that? That's really long. So let's pick out our important points here. When you have questions like these, with a backstory, always try to pick out the important points that you need. So we know that we have to write a system of equations, so we should pull out the points that will help us write those two equations. So first of all, Anna wants to spend $30, right? We know that the balloons cost $2 each, and the party hats cost 150 each. Then the number of party hats Anna needs is twice as many of the number of balloons. And X represents the number of balloons. That's horrible. X represents the number of balloons. Why is the purple not lining? Oh, okay, cool. Okay, X represents the number of balloons and Y represents the number of party hats. Okay, let's write our first system. Let's write our first equation for the system. So Anna is planning to spend $30. So I know whatever she's spending, whatever the cost is, that has to be equal to 30, right? Then I know that the cost of the balloons is $2 each, and X is representing the number of balloons. That means the cost of the balloons is 2X, right? $2 per balloon, $2 for each balloon. So that is 2X. And then the party hats cost $1.50 each, and we're using Y to represent the party hat. So 150 Y. 150 for every party hat, right? 150 for each Y. So plus 150 Y. And that has to equal to $30 because that's how much she's planning to spend. Then the next part says the number of party hats Anna needs is twice as many as the number of balloons. Well, the party hats is represented by Y. So Y is equal to party hats that she needs is twice the number of balloons. When I'm thinking about twice of something, I'm thinking about two times, right? Two times that amount. It's doubling. So party hats is twice, two times the number of balloons, and balloons is represented by X. So it's Y equals 2 times X, right? Twice the number of balloons. That part's a little bit tricky. You just got to think of it carefully. So that's it. Now I have the two equations. I have the system, and we were asked to graph this system. So let's start by graphing the y equals 2x. So y equals 2x is already in slope-intercept form. We are not told what a y-intercept is specifically. When we're not told what the y-intercept is, we know that it's always going to be 0, right? Right at the origin. So my first point is going to be right down here on 0, 0. And I have 2x, so my slope is 2. So I'm going up 2, right 1. Up 2, right 1. Connect those points with a line. Okay. Notice that I'm not going to put arrows on this line because um Anna only has Anna only has $30 to spend. So I can't keep buying more and more balloons, right? At some point, I'm gonna run out of money. Not me, she's gonna run out of money. So this line has to stop right here, um, where the graph is ending. So don't put arrows on a line that has a constraint in the equation, right? It has to be if it's equals to a value like this is equal to 30, the line would not carry arrows. Okay, let's graph the second equation. 2x plus 150y is equal to 30. The 2x plus 150y is equal to 30 is not in slope-intercept form. So to be able to graph that, we need to put it in slope-intercept form. We have to put it in y equals. We have to solve for y. So let's do that. I'm going to start by subtracting the 2x from both sides because I need to get the 150 by itself. That's going to cancel. I'm left with 150y is equal to 30 minus 2x. Last step to get y by itself here is to divide both sides by 150. This cancels, and I'm left with y is equal to 30 divided by 150 is 20, and then -2 divided by 150. We don't want to work with decimals when we're graphing here, so let's put that in the calculator to get a fraction. -2 divided by 150. What is it, like 1.333 negative, yeah, -1.333. Let's convert that to a fraction. We hit SD, -4/3. So y is equal to 20 minus 4 thirds, and don't forget the x, right? 20 minus 4 thirds x. So if I'm graphing this, I'm starting at 20 because 20 is my y-intercept in this equation, all the way up here. And then my slope is -4 thirds. So since it's negative, I know that I'm going down. Top number, numerator is 4, so I'm going down 4, right 3. And connect these points with a line. Again, notice I'm not putting arrows on these lines because at some point Anna will run out of money. So there's not an infinite number of solutions here. And then we're asked to identify the solution. Before we do that, we need to label our lines. So our blue line was y equals 2x. Once we have labeled one of them, we're good. I always just like to label both of them for some reason. I don't know. I feel like it looks better. Okay. And then we're asked to identify the solution, right? So again, obviously your solution is the point where the lines intersect, which is right here. What's that point? So that's on the x-axis, that's 6, and on the y-axis, that's 12. So our point here, our solution is 6, 12. So we're also asked to explain what it means in the context of the problem. So our solution is 612. What does this mean? This means that the number of balloons that Anna can buy is 6, and the number of party hats she can buy is 12. If she buys 6 balloons and 12 party hats, she will spend $30. So let's just write that out. Anna can buy 6 balloons and 12 party hats for 30 $30. Right? And also in our equation, y equals 2x, right? Party hats is double the number of balloons. 12 is double of 6, right? 6 times 2 is 12. So that also checks out, that works. Is that all? Yay, that is all. Okay, so that was all for this little review. I think I over-explained on a lot of these, but I hope it was helpful in some way. Okay, bye guys.